So in this next lesson for homework packet 3.3, we're going to look at solving, instead of exponential equations, we're going to look at solving logarithmic equations. So because of the relationship between logarithmic and exponential functions, we're going to see that there's some similarities with how we solve them. We saw that with exponential equations, there was a point at which we had to convert from exponential form into logarithmic form in order to be able to finish solving. What's going to be true with logarithmic equations is that we're going to have to convert from log form back into exponential form in order to be able to finish solving the equations. So let's practice that really quick. I've got log form right here, and I want to convert it into exponential form. So we remember that y equals b to the x is the same thing as x equals log base b of y. This is the form that I'm in here, and I want to be in this form here, exponential form. Okay? So remember the trick. Always start with what's in the logarithm. For us, that's f. So f equals the base value. F equals the base value. The inside part, the of part, equals the base value raised to the power of whatever the logarithm equals. So f is equal to 3 to the t. Using that same logic here, always start with the of part. Remember, you got log base b of y. The of part for us is 15. So the of part of the logarithm equals the base value. So 15 equals h, but it's h raised to the power of that other side, s. Okay, so being able to convert from log form to exponential form is going to prove helpful when we look at these next examples of how to solve a logarithmic equation. So in our first example here, we have an equation that says 3 times the log base 4 of x plus 13 equals 34. First thing that we need to identify is this. Is the 13 a part of the logarithm? The answer is no. What would make the 13 part of the logarithm? If the x plus 13 was in parentheses. So only the piece right next to the logarithm is in the logarithm unless there's a grouping of things inside parentheses. So it's 3 times the log base 4 of x, and then plus 13 equals 34. So just like exponential equations, let's do the things that we already know how to do, like subtract 13 from both sides, because the goal is to solve for x. So this leaves me with 3 times the log base 4 of x is equal to 34 minus 13, I believe, is a 21. Okay. And then it's 3 times the log base 4 of x, so I can divide the 3 away. Divide both sides by 3 produces the log base 4 of x is equal to 21 divided by 3 is 7. So what I do is I remove everything from around the logarithm first. Now at this point, the value that I'm solving for, x, the variable that I'm solving for is inside the logarithm. I can't solve for it unless I get it out of the logarithm. And here's one thing that some people like to try. Just divide both sides by log base 4. That doesn't work because the x is a part of the log base 4. Remember, this is one chunk of stuff that can't be broken up. It can only be converted from log form into exponential form. So remember, to convert from log form to exponential form, start with the of part. That's x equals the base value. So x equals 4 to the power of whatever the logarithm is equal to. So x equals 4 to the 7th. So doing that on our calculator really quick, 4 to the 7th, I'm getting that x is equal to 16,384. So there's the solution to this equation right here. 3 times the log base 4 of x plus 13 equals 34. What value of x makes this statement true? If x is 16,384. We're going to look at 2 more examples to drill this concept home. we've got 52 equals 7 times the log base 3 of x minus 12. Notice in this case, the entire x minus 12 is the of part of the logarithm because it's in parentheses. And then plus 16. So let's do the basic stuff first. Let's subtract 16 from both sides. What is that? 652 minus 16 is 36. 36 equals 7 times the log base 3 of x minus 12. Okay, now I have 7 times the log, so I'm going to divide the 7 away. Let's divide both sides by 7. And I end up with approximately 5.14 is equal to log base 3 of x minus 12. Now the only thing I have left over here on the side that has the x that I'm trying to solve for is the logarithm. So this is the point at which I convert from log form into exponential form. So what does that look like? Start with the of part. That's the x minus 12. X minus 12 is equal to the base value, which is 3, raised to the power of that other side, 5.14. So in my calculator, I'm going to do 3 to the power of the 5.14. I'm actually using the exact value because that's already stored in my calculator. And I'm getting that x minus 12 is equal to 284.29. 284.29. Okay. Now, interestingly enough, I'm not done solving for x. I still have to add 12 to both sides. So that brings me to x equals 296.29. That's the value of x that if I were to plug it in for x of this original equation, it would make this statement true. In other words, each side would equal each other. Last example here, and you'll notice that it involves a natural logarithm. So we'll remind ourselves of that. Let's start solving this like we have the others, the basic stuff first. Subtract 15 from both sides. So 52 minus 15 is 37. So that's 37 is equal to 6 times the natural log of 2x minus 4. It's 6 times the natural log, so I'm going to divide by 6. And I'm going to get a 6.17 is equal to the natural log of 2x minus 4. Okay. So I peeled away any addition and subtraction, and I peeled away any multiplication and division. So I'm left with my logarithm here of the natural log of 2x minus 4 is equal to 6.17. This is the point at which I convert to exponential form. Now careful here, because what is the base value of natural log? If we remember, the base value of natural log is that value of e. Remember, because the natural log is the same thing as log base e. So when we convert, we always start with the of part. That's 2x minus 4 is equal to the base value. What did we just say the base value of natural log is? It's e. So it's 2x minus 4 is equal to e to the other side, 6.17. So 2x minus 4 is equal to, remember the e button's right above division. So I'm going to do a second e to the power of 6.17. I'm using the exact value because I have it stored. And I am getting 476.59. To finish off solving for x, I have to add 4 to both sides. So that's 2x equals 480.59. And then I have to divide by 2. So that's x equals 240.30. So the value of x that makes this original statement true is x equals 240.30.